So we did first derivative tests, which told us about increasing functions, and then using increasing and decreasing, we were able to imply where we had maximums and minimums, right? So now there's a second derivative test that tells you about concavity. So first derivative tells you increasing, decreasing. Second derivative will tell you if a certain section is opening upward, concave up, or opening down, concave down. Okay, so that's what we're gonna do. So this is problem, hoping you read the theory or watched the video on the theory a little bit. And if not, hopefully we all figure it out. Problem 2, determine the open intervals on which the graph is concave down or up. So you're gonna have to take two derivatives. You're gonna also need to find out, probably gonna need the critical values, but we'll get there in a second. Determine the open intervals on which the graph is concave downward or upward. So here's a function they give us, 6x squared minus x cubed. Okay, so first derivative, what's the first derivative?
12x minus 3x squared.
Okay, what's the second derivative?
12 minus 6.
12 minus 6. Okay. So again, just write a note here. This tells you the first derivative about increasing slash decreasing. This tells us about concavity and inflection points. Helps you find them, I guess. By the way, an inflection point is a point where we have a change in concavity. Okay. Usually it has one S, right? It looks weird. Usually when second derivative equals 0, that's where you will find a inflection point. Okay, so let's practice what we talked about last time, because it was a while ago. So first, set this guy to 0 and find your critical points. That's what we did, right? Set G prime to 0. Right? Now wait a bit, because I know I've said a lot of stuff.
x equals -12?
I think so. Well, factor 12x out, we're gonna get x, oops, sorry, 3x. 3. That'll be 4 minus x equal to 0. So x equals 0, x equals 4. These are the critical numbers. So just remind you what we did on Wednesday, or whenever that was. I don't remember. Set g prime to 0, and we'll find the inflection point. So x would be 2, right? So this right here is your inflection point. So basically the section's about trying to use derivatives to figure out what a function is doing. Okay. Let me write you some notes here. If the second derivative is equal to 0, at some point, let's say at some x equal to c, then c is an inflection point. If the second derivative is positive at x equal to c, then the graph of the function is concave up. By the way, this implies a minimum. If the second derivative is negative, then the graph is concave down. This is a max. So similar to the second one, I'm just shorting it up because I'm out of space. Exact same thing, but opposite. Wait a bit. Anyway. We didn't answer the question, we just got distracted. So a good idea is to draw a number line, put the inflection point and your critical numbers, and use the second derivative to figure out what's going on. You can also figure out, if you plug in the criticals into second derivative, there's a good chance you can figure out if it's a maximum or minimum. But they didn't ask about that. All they asked was, where are we concave up, where are we concave down? So we need to check below the inflection, above the inflection to answer the question. For above 2 and below 2. Yes, cool on this page. All right. So use the second derivative test to determine max and min. Well, we'll do that. To determine concavity and maximum. Okay.
You say it's a max because it has a minus 6x.
Well, hold on. Let me show you. So let's put the inflection point right here. Let's put the critical over here, and we had another critical at 0, right? So first question, concavity. Plug in into the second derivative. We call it G or F. Plug in G 0. So that's gonna be, what was the second derivative? 12 minus 6x, right? That gives me 12. So we're positive over here for concavity. So that means we were concave up. Double prime, plug in the 4. That gives us 12 minus 6 times 4, which would be 12 minus 24, right?
-12.
So negative. So that means we're concave down. So we have this kind of thing going on. So below 2, it's concave down. Then after 2, it starts to go, I'm sorry, concave up. So it's going like this. Then right after, it starts coming downward. Okay, so we can actually create a sketch if we wanted to. But anyway, question asked about concavity. So we are concave up from negative infinity all the way until 2. We are concave down from 2 to infinity. This is all they asked for. Okay. So very similar to the first derivative test where you test below and above the critical. Here you just test below and above a inflection point, because we said inflection point is where it changes concavity. So it's concave up until here, and then it's concave down. But if it's concave up here, that implies that there's a maximum at 0. I'm sorry, over here, 4. Concave down is max. Minimum at 0. I'd have to plug this into the original to get the value, the y value. But that's a general idea. To give you a picture though. You can see what the heck's going on. So the original was something. 6x squared minus what?
X cubed.
Like this, right? Okay. So here is the critical number. Right? And we had an inflection point at x equal to 4? No, 2. So we said we're concave up, we can see it, right? From negative infinity all the way until 2, and then it changes to concave down after 2. Does that make sense? So that's what we're trying to figure out. Like when is it opening upward, and when does it change to opening downward? And we were able to do that with the second derivative. Now, if we plug in critical numbers into the second derivative, that will tell us that it's a minimum, because concave up means opening upward. So this has to be a minimum point. Plugging in the 4 gave me a negative opening down, which gives me a maximum, or local max. Local. Does that make sense?
Let's see, what did you say? So when you said negative infinity to 2?
Yeah,
It's
negative infinity
concave
to 2. Concave up, opening upward.
Chance this.
What's up?
Back into so this one's right.
Sorry, what did you say?
Because the negative infinity to 2 is going up.
Yeah, opening up.
Oh, so don't look actually the graph.
Yeah, concave means it's opening upward.
Open up. Oh, yeah, that's what I'm thinking. It looks like when I'm looking at it from left to right, the graph looks like it's going down, but we're not necessarily looking at just that one graph following this point.
Yeah, so the blue line, I put a barrier there so you can see that's when it changes to opening down.
So x would be 432, right? And then under would be 0, 0.
Yeah. Anyway, so those are all the ideas about second derivative tests. Any questions about this? Does that make sense? Okay, you guys cool on this page? Go back to the questions. That was number 2, right? There it is. So all they wanted was these intervals. We answered more stuff just because. So example 3, let's do the same thing. Take 2 derivatives, set to 0. That'll be your inflection point, and then test below and above. That's technically all we are doing. Find the intervals for concave up and concave down. F of x is equal to negative x cubed plus 3x squared minus 7x plus minus 1. Minus 1. Take a derivative. What will be the derivative? You guys are all pros now, right?
3x. 6x. 7.
Okay. Set this to 0. So I'll make a note here. Find the inflection point. By setting the second derivative to 0. Step 1, find the second derivative. Step 2, find the inflection point. So negative 3x squared plus 6x minus 7 is equal to 0. Factor this guy. Oh, actually, I'm sorry. That's the first derivative. Second derivative would be what?
Six x plus 6.
So let's factor this one. All right. Looks like x is going to be what? Negative 1. Okay. So test around negative 1. So I'm going to choose 0. I'm sorry, 0 is over here. This is negative 0. Just kidding. Okay. Step 3. Plug in values for I should say below and above the inflection point. Oh, nice. Okay. So F double prime at -2, that would be -6 times -2 plus 6, which would be 12. No, 18. F double prime at 0 would be -6 times 0 plus 6, which would be 6. So what does that mean? Is that right? Did I mess that up? Let me double check everything. Oh yeah, here's a mistake. This is +6, which means this is +1, which then means I'm gonna change my decision here. 1's right there, 0 is here, 2 is here. I'm gonna choose these numbers instead. So here's 0, that was positive. I'll use +2, which means that this is now negative. There we go. Sorry about that. You guys still with me? So after 1, the inflection point, we are concave down. So concave up would be -infinity all the way until the number 1, because after 1, we change concavity. Concave down from 1 to infinity after 1. That's all he asked for. But we could find max and mins if we wanted to, but we'll do that later. I feel like we should have one straight to the point example. Hmm. Any questions on example 2?
So what?
So
Oh no, I'm tired.
okay, I'm sure we all are. You gotta stop staying up late on Sunday nights. I don't work, I just stay up and just doing stupid stuff. Yeah, basically. Bad choice.
This is like so much trips and I'm all tired.
That sounds rough. I don't know how you can drive home, man.
I don't remember getting it to San Antonio, so.
Oh, shit.
Sleep later.
Late on a Sunday, you don't get enough sleep, gotta work on Monday. These damn circuits have you doing some stupid stuff, they have me holding up somebody's arm straight up so they can work right here. You ever try holding somebody like this for an extended period of time?
Oh yeah, I'm pretty sure your arms were burning.
Yeah, it hurts, dude.
They couldn't like just tie something, hold them up or something. Yeah, I feel like you could have rigged something up pretty easily, you know?
You can't put unsterile stuff over a sterile area.
So you have to sterilize some handcuffs, maybe? That might work. I mean, it might be a little weird, but it could be fun.
I think it's because like where it's negative doesn't match
What's
up,
up?
and where it's positive isn't matching up.
Okay,
I
so
think there's my.
Like you should have did the 0 on the left.
Yeah.
I don't know what that's about, but it's witchcraft.
Set up like magic. No, I think I probably figured it out. I think that's why, because it's not matching up with the.
Move looking straight up.
So, okay, remember, this is the inflection point. So I check below 0 and above 2, right? So here's the 0 one. So that was positive, so I put a plus there. Plug in 2, got negative, minus.
It's all crisscross.
I mean, I guess it's been better.
I like it.
Want me to erase it for you?
No, you're.
I'll fix it.
No. I have it written down right here, and it just wasn't.
Oh, you wrote it correctly. You wrote it the other way?
Yeah, because I was looking at yours and like it wasn't originally, it wasn't matching. I just couldn't figure out what was going on.
No, yeah, I see what you're saying.
And I was like, wait.
Yeah, I wrote it this way because it was, I didn't have to erase anything.
Like your whole like starting from number 2 wasn't matching up with what I.
Mhm.
It's sooner better.
Yeah, I hate, Mondays are very long for me too. So-
I've been at work since like 6 o'clock this morning in the first place, so yeah.
Same. This word want. Don't quite understand that right now. Let's see. Just you guys. Yeah, I treat them like crap. It's really, really bad. Just kidding. All right, let's do example 3, problem 10. So you usually don't work Mondays, right?
I work Saturday, Sunday, Monday, Tuesday.
Oh,
But they're
okay.
12-hour shifts.
Gotcha. I thought it was like just Friday, Saturday, Sunday or something.
Friday I won't. Friday's like the only day off.
But it's usually just catching up on stuff. I hope you had a nice spring break at least. Did you get some actual fun time?
It's sitting in panic
You're sitting in panic?
the entire week.
Why?
Spent.
Just because,
If you've been a student, you know what a week spent in panic. It's like, don't lie to me.
no, I'm sure. Sure.
You don't know what that is.
No, I was wondering why you were in panic. But it was because of school.
That's probably- Yeah, an entire week. Stuff like that.
I figured you could see it as an opportunity to take your time and catch up, you know? Instead of being, being rushed or having more stuff piled on. I suppose that is an option.
2x squared.
1/2 x to the 4th plus 2x cubed. So that's a crappy 3. That's the worst 3. Okay. Believe it or not, I practiced my handwriting. Tried really hard to get better. It's as good as it's gonna get.
It's better than doctors. Sure. They write like prescriptions and shit for meds that can kill you if we get it wrong. So like, just saying.
Yeah. Yeah. They do write horrible. Okay. So let's take 2 derivatives and see what happens. So we're gonna have, bring that 4 down times 1/2, that's 2, right?
2x cubed.
Plus, yeah, you got it, nice. Second derivative, what's gonna be?
X squared.
Got confused there for a second. 6x squared plus 12x, right? Okay. Find the inflection points. So this one we're gonna have more than one inflection point. Okay. Factor. So we get x equal to 0 and x equal to -2.
Or we knew the x equals 0, but there's the x on the outside.
Yeah, there's only way, if you set a 6x to 0, it's gonna be this. Okay, so we got 2 inflection points. There it is. So it wants, well, we found the x values. So we're gonna need the y values if we're gonna write down the point. So plug x equals 0 and x equal to -2 into f of x. So f of 0 gives me 0. F of -2 is gonna be something, I don't know. Be -2 to the 4th, that's what? 16 times 1/2 is 8. This would be 16 -8. So inflection points be 0, 0, and -2, -8. So that's what they wanted for part A. They wanted you to find the actual location point. I thought they just wanted the x, but they said points.
Just find the points and plug into the original values. They just wanted the
Well, all they asked for was where is it in, concave up or concave down. So we didn't need the values of themselves. We just need the x value. Okay, any questions on finding the points? Part B, find where f is concave up or down. How long did you have to hold the arm up?
30 minutes.
Dang.
This dude,
Yeah, it's really.
Like 5 minutes. Now.
yeah. So this dude had been on a motorcycle when he went down and crashed, right? All things considered, not as bad as it could have been. I've seen way worse. He just broke his arm. So it was this ulna, and he had to rearrange it. And right here in the center, the fucking thing was a little jigsaw puzzle.
Oh, it
So
was
the
like
only way to
shattered?
get it to actually go back in place is if I pulled really hard and rotated it just right. Well, they pushed down on the other side to force the bones to kind of straighten out into place.
Sounds like a
Yeah,
creepy puzzle.
yeah. So we just stretch it and rotate it, and it'll make them go back into place, and then we clamp it, clamp it, and screw it all back together.
Ouch.
Yeah, it's
Yeah,
he has an arm again.
that's true. But you have to have it open so you can see how it's
Oh,
fitting.
yeah. So we slice all this open, so we can work on
That makes sense. Otherwise, how would you know? Like, did I get it?
it.
Creepy. Well, I'm glad you fixed his arm.
Y'all sometimes leave shit in there. So, no one's ever gonna know about it. Except it doesn't. Just put a piece of.
This guy
Because
had
it's extra
previously-
cold during the winter.
This guy had previously gotten shot. Like he'd gotten shot by I think a shotgun,
Ouch.
like pellets, right? So, well, we're taking X-rays of his arm, and it's just littered in little black dots, and those are all the pellets from his previously being shot by a shotgun.
So he never took him out?
No, we can't get all of them out. It's like hundreds. So we would cause more harm trying to get them all out than if we just leave them where they are.
No, I meant like when it first happened to him. Oh,
It's
well,
not.
I
I
wonder.
mean, they were scattered. So we honestly can't get them all out. So
And
when
they
you're
don't,
looking at
like-
his X-ray, it looks like a normal X-ray, right? But there's just dots everywhere. Where the
Wow.
bullets are.
And they don't like cause infection or anything?
I mean, they can, but this was a long time ago that he got shot.
I guess I figured it eventually would cause some sort of infection in there.
The
Crazy.
doctor was actually like talking to the guy because he was awake while we were working on it. Yeah, I mean, he had some kind of condition where we couldn't put him to sleep.
Oh,
So we just blocked his nerves and then worked on him while he was awake. And
that sucks.
the doctor's like, so how did you get shot, dude? He's like, I was in a gunfight. I was like, cool. I was like 16. I was like, cool.
I like it.
16 in a gunfight.
Just normal high school stuff. Jeez. All right. All right. That's crazy. All right. So part B, concave up or down. We have the flexion point 0 and -2, right? So I'm going to test around these 2 points. So just pick any number. I picked these. Plug them into F double prime. So F double prime at -3, that's going to be 1/2 times negative. Well, where's double prime at? Yeah. 6 times -3 squared plus 12 times -3. Right? What will that give us? Is that negative or positive? This would be positive 9 times 6. It's 9 times 6. 54 plus 12 times -3. That's going to be positive, right? So or plus. Who cares what the number is? As long as it's plus, or put a plus. Plug in -1. We'll get 6 times -1 squared plus 12 times -1.
Go with negative.
What's up?
I guess negative.
Yeah, it looks negative to me. Okay. F of 1 will be, yeah. Okay, so now we can answer the question, right? So concave up negative infinity to the inflection point. 2. And then union, because we're concave up after 0 to infinity. Right? We're only concave down in a small section. Concave down will be -2 to 0. Any questions on this problem? You guys okay? Okay, so test before, after, in between, and then we got these intervals. That's all they asked for, I think. Part B was just find that. Part A was find the actual points, which we did. This was part A right here. Okay. That last example for this section will be example 4. You guys cool on this page? Find all relative extrema. So this time we're going to find max and mins using the second derivative test. Okay, so we're going to need the critical numbers and the inflection points. Most likely. So first derivative. Second derivative. Okay. Okay. Set this to 0 for critical numbers. Factor the 4x squared, and we get x minus 3. So x is 0, x is 3. inflection. Set this guy to 0. Factor your 12. That gets us x minus 2. So x is 0, x is 2. Okay. So now, plot the critical numbers. I'll put C's on them, I guess. Well, this happens to be both. It's interesting. I'll put a star on the inflection. Critical number, I'll just put a C on it, I guess. This happens to be both. Okay. We technically don't have to worry about testing anything in between. They didn't ask about any of that stuff. They just want to know extrema. So we don't have to do any work other than let's plug the criticals into the second derivative. So I'm not going to worry about this. Second derivative at 0 will be 12 times 0 minus 24 times 0, which is 0. Second derivative at 3 will be 12 times 3 squared minus 24 times 3. That's 9 times 12. What's that going to be? 3 times 24. 22. Or this guy, right?
36.
12 times 9.
The whole thing. 12 times 3 squared minus 24 times 3 is 36.
Oh, you got the whole answer is 36. Oh, gotcha. Okay. So that means we are concave up, right?
Sorry.
36. 36 is the total. Might as well now that I wrote it already. Might as well. Okay. So since f double prime at 3 is greater than 0, then we have a minimum because it's concave down. So plug in f of 3 to find out the location to the original. What's that total?
Is that concave down or up?
Down. I'm sorry, up, yes. -20? Cool. Yeah, that's right. That's right. So 3 comma -20 is the minimum. Or local. Yeah, it's the extrema, relative extrema. All right. So that's it for section, whatever that was. 4 point. Let's see, yeah, 4.4. So that's the second derivative test. Tells you what concavity, and it's another way to find max and mins. Second derivative also helps you find inflection points. So we did all that stuff. Cool. 4 or 5 will be chill. We've kind of talked about that already. 4-6 is, I'm not gonna like that one. 4-7, you're not gonna like that one. 4-8, probably gonna skip. I'll skip 4-8. So don't do 4-8. So we are. Say, well, I guess we can stop here. On Wednesday, we're gonna probably have to do 4, 5, and 4, 6. So it's probably gonna take the whole time. Because 4, 6 is a little long. Yeah, let's do that. We'll see how it goes. Guys, have any homework questions or any issues you want to go over instead?
The last one that we just did.
Yeah.
You went straight to 3 on that because 3 was the concave point.
3 was a critical number.
Critical number. 0 was 2. We don't worry about 0.
Yeah, because when we plugged in the same derivative, it gave us 0. So it was an inflection point. So it was not considered for extrema. So at first it appeared it could have been a relative max, but as soon as I saw that the second derivative is also 0, right, when we did this work, we got 0 for both. That was like a hint that it's not going to be a relative extrema. But then when you try to test for it, I didn't get a positive or negative. I got 0.
So like at the very beginning, we had find all relative extreme. Could I put on there parentheses next to extreme, like critical points or?
Extrema just means the local minimums and maximums. So wherever you have like a peak or a valley, that's what they mean.
We won't know that from the critical points until we actually put them in.
We have to either use first derivative test to test around the critical number, or plug the critical number into the second derivative to find out if it's opening up or down.
That's what I remember you said it's potential. Critical potential.
Yeah, we gotta test it. That's what we're doing. That's why we have 2 tests now. First and second derivative tests.